Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. We are talking about the sampling, distribution and test of significance. In the earlier session, we have studied some terminologies related to test of significance, and we are studying the large sample test. In continuance with the discussion about sampling, distribution and large sample test, in this session, the objective of this session is to work out some problems in large sample test for difference of means and a specified standard deviation. Interval estimation of the population parameter is also done. So, we will go ahead with the next example in continuance with the large sample test. So, a sample of heights of 6400 Englishmen has a mean of 170 centimeters and a standard deviation of 6.4 centimeters, while a sample of height of 1600 Australians has a mean of 172 centimeters and a standard deviation of 6.3 centimeters. Do the data indicate that the Australians are on the average taller than the Englishmen? Okay. The information is given in the question. We will go ahead with testing the significance between the Australians and Englishmen using large sample test for difference of means. First of all, let me write down all the values given in the question. That is, the whole paragraph will be now turned mathematically. It is clear there are two types of samples given. One is Englishmen and another one is Australians. So, let me take Englishmen as the first sample, sample 1, and Australians as a sample 2. So, they are totally population 1 and population 2, totally different populations. Therefore, now N1 is equal to 6400, x1 bar is equal to 170, this is mean, and standard deviation S1 is equal to 6.4. Okay. And about Australians, there are 1600 Australians, right. Therefore, N2 is equal to 1600, x2 bar is equal to the mean 172 and S2 is equal to 6.3. So, the whole paragraph is now converted mathematically as N1 is equal to 6400, x1 bar 170, S1 6.4, N2 1600, x2 bar 172 and S2 is 6.3. Okay. So, first of all we will set up the null hypothesis H naught. H naught is mu 1 is equal to mu 2, this is mathematical representation, and in words the question is, do the data indicate that Australians are on the average taller than Englishmen? According to H naught, both Australians and Englishmen are equal, that is equal in the sense they are not taller, right. So, the Australians equal in the sense has been written as Australians are not taller than Englishmen. For sake of clarity with alternative hypothesis, it is written as not taller. Actually, H naught means Australians and Englishmen are equal in height. So, step 2, H1, I will use the notation later. First, let me write in words. Australians are taller than Englishmen. Australians are taller than Englishmen. Australians are represented as sample 2 and Englishmen are represented as sample 1. Therefore, taller in the sense mu 2 is greater than mu 1. This implies H1 is such that mu 1 is less than mu 2, and this happens to be left tailed test, right, left tailed test. So, it is one tailed, the whole test is one tailed test. Okay. Next, step 3, we will fix up the level of significance as 5%. Nothing is specified in the question, means you have to automatically take the level of significance as 5%, or you can take any level, accordingly the tabulated values will differ. So, let me take a level of significance as 5%. Next step, step 4. Step 4 is computation of Z value. Z is equal to x1 bar minus x2 bar divided by root of S1 square by N1 plus S2 square by N2. We will substitute all the values written there. X1 bar is 170 minus 172 divided by root of 6.4 whole square by 6400 plus 6.3 whole square by 1600. So, it is minus 2 divided by root of 0.0064 plus 0.0248, and this value is minus 11.3. So, calculated Z at 5% is equal to modulus of minus 11.3 is equal to 11.3. So, tabulated value at 5%, as already discussed with the table of one tail test, tabulated Z at 5% means tabulated Z at 10% at two tail test. Okay. So, at two tail test the tabulated value is 1.645. Now, conclusion says calculated value Z at 5% is greater than tabulated Z at 5%. Okay. Therefore, H naught is rejected. H naught is rejected in the sense H1 is accepted. It means Australians are taller than Englishmen. Australians are taller than Englishmen. This is the conclusion we arrive at in this particular case. Next, interval estimation. There is no separate formula for interval estimation. All the formula you are utilizing for normalizing the variable itself gives you the formula for interval estimation. For example, we have seen Z test for single mean, right. What is the statistic formula in there? Z is equal to x bar minus mu divided by sigma by root n. The question will be asked to find an interval estimate for the population parameter mu, right. So, what you have to do, the tabulated Z will be given, x bar will be given and sigma will be given, n value will be given. So, all the values are given, means you have to just cross multiply, take that x bar to the other side, you will get the value for mu. That is what is interval estimation. A simple random, let us see how this goes. A simple random sample of size 100 has mean 15, the population variance being 25. Find an interval estimate of the population mean with a confidence level of 95% and 99%. What are the values given in the question? N is equal to 100, mean x bar is equal to 15. Population variance is being 25. So, population variance is sigma square is equal to 25. You are asked to find an interval estimate for the population mean with confidence level of 95% first. So, confidence level 95%, implies level of significance is 5%, 100 minus 95, 5%. Okay. Therefore, we will write down the formula Z alpha is equal to plus or minus, because it is in the modulus you will have to write the plus or minus x bar minus mu divided by sigma by root n. Okay. And Z at now substitute all the values, Z at 5% is equal to plus or minus x bar value is given to be equal to 15, mu only we are finding. So, mu is kept as it is, and sigma square is 25 implies sigma is equal to 5 root of 25, 5 divided by root of n is 100. Okay. And Z at 5% from the tables is 1.96 is equal to plus or minus 15 minus mu divided by 5 by root 100. Root 100 is 10, 5 by 10. 5 by 10 is also 1 by 2, just cross multiply this value. Cross multiplying 1.96 into 1 by 2, 5 by 10 comes in there as 1 by 2 is equal to plus or minus 15 minus mu. We want this mu value. So, mu is taken to this side and 1.96 by 2 is taken to the other side. It becomes mu is equal to 15 plus or minus 1.96 by 2, and the value of mu are one value with adding 15 with 1.96 by 2 and another value by subtracting with 1.96 by 2. So, what is that value? 0.98. So, that is mu is equal to 15 plus or minus 0.98, that is one value is 15 plus 0.98 and another value is 15 minus 0.98. 15 plus 0.98 is 15.98 and another one is 14.02. So, when you want it in the interval format, 95% confidence interval will be 14.02 comma 15.98, because smaller value should be written first, it is in the interval format. Or if you want the limits are the end points of the interval will be called as limits. So, 95% confidence limits if you want, they are 14.02 and 15.98. 95% confidence interval for the first subdivision. The second subdivision is about 99%, right. Second subdivision is find an interval estimate of the population mean mu with a confidence level of 99%. 99% means 99% confidence level if you want, it means 1% level of significance to be taken. Okay. So, accordingly Z formula will differ. Z at 1% is equal to x bar is 15 minus mu divided by 5 divided by root of 100, everything is same. Okay. Z at 1% only will differ and the value is 2.58 is equal to plus or minus should be there, 15 minus mu divided by 5 by 10 is 1 by 2 here. And just reorganizing like in the previous subdivision, we have 15 plus or minus 1.96 1.29. Okay. So, one value with 15 minus 1.29, another one with 15 plus 1.29. So, the values are 13.71 comma 16.29. So, 99% confidence interval. Interval means it should be written in the brackets, interval format, 13.71 comma 16.29. And similarly 99% confidence limits are endpoints are 13.71 and 16.29. This is a similar problem, but with the finite population. Let me see how this goes. A random sample of size 100 articles from a batch of 2000 articles showed that average diameter of the article is 0.354 with a standard deviation of 0.048. Find 95% confidence interval for the average diameter of this batch of 2000 articles. Here the sample of 100 articles has been taken from a finite population of 2000 articles. So, your standard error will differ. How that goes? Here the sample size is 100, but the population size is 2000. So, it is represented with a capital N, population size is represented with a capital N, and x bar is equal to 0.354 and S is equal to 0.048. When the population value is not available, you can have to use the sample standard deviation value. Find the 95% confidence interval for the average diameter of 2000 articles. So, the formula goes like Z is equal to x bar minus mu divided by sigma by root n into root of capital N minus n by capital N minus 1. This is only the slight difference in the formula for finite population. Okay. Now, in this problem the population standard deviation is not available, therefore, we have to take a sample value. So, in the place of sigma you will have to write S by root n root of capital N minus n by n minus 1. This is Z value, right. You are asked to find out for interval estimation for mu, and 95% confidence interval implies 5% level of significance. So, let me substitute all the values. Z at 5% is equal to x bar is 0.354 minus mu divided by S is 0.048 by n is root of 100 into root of capital N is 2000 minus 100 divided by capital 2000 minus 1. Okay. This is within plus or minus, just cross multiply. Z at 5% is 1.96 into cross multiplying that value is 0.0048 into root of 1900 by 1999, and the x bar value is 0.354 minus mu, and this is within plus or minus, accordingly we have to take. So, 0.00915, or you can take this plus or minus here, is equal to 0.354 minus mu. So, mu is equal to 0.354 plus or minus 0.00915. Okay. So, the values are 0.34485 comma 0.36315. This is your 95% confidence interval. Now, this problem is slightly different, wherein you have to calculate the sample size, whereas the interval estimation value is being given. With a sample size of 400, the calculated standard error of mean is 2. Standard error of mean is given, and with a mean of 120, what sample size would be required so that we could be 95% confidence that the population mean is within plus or minus 3.5 of the sample mean. Z value with 95% confidence for two-tail test is 1.96 is given. Okay. Now we will go ahead with finding the sample size n value. Okay. First given information is for SC of x bar is equal to 2, n is equal to 400. Using this we have to find out the population standard deviation. As standard error of x bar is given by the formula sigma by root n is equal to 2, n is 400, therefore sigma is equal to 2 into root of 400. 2 into root of 400 is 40. So, you have sigma value is equal to 40, and the formula for n sample size is Z at alpha percentage into sigma divided by this is probable error whole square, where E stands for probable error. Probable error is different from standard error. This error is caused due to randomization, whereas standard error represents a standard deviation. All the values given in the question is Z at 5%, because of 95% confidence level we are taking 5%, Z at 5% is 1.96, and sigma just now we have found out it is equal to 40, and the probable error allowed for mean is plus or minus 3.5. So, n is equal to 1.96 into 40 divided by plus or minus 3.5 whole square, and this value gives you 501.76. Therefore, n being a number is 502, rounded off to the nearest whole number. Now, continuing with the large sample test, so far we have studied Z test for single mean and Z test for difference of means. Using Z test for single mean and Z test for difference of mean, we have done a problem. We have done problems in estimating the intervals of the population parameter. Now, in continuance with the large sample test, the next test is test for specified standard deviation of the population. First of all, set up the null hypothesis, alternative hypothesis, etc. The procedure goes like step 1, H naught you have to set up a sigma value, that is population standard deviation value is taken as H naught, and in step 1 you have to contradict H naught by saying it is not equal to or sigma is greater than a particular value or sigma is less than a particular value. Step 3 is fixing up level of significance. Step 4 is calculation part, Z is equal to S minus sigma divided by root of sigma square by 2n. S minus sigma by root of sigma square by 2n. This is the formula, and step 5 is usual conclusion step. Okay. Now, this problem is about testing the single standard deviation. The standard deviation of a sample of size 50 is 6.3. Could this have come from a normal population with standard deviation 6? So, the solution is from a sample of size 50. So, n is equal to 50, sample standard deviation is given to be 6.3, and this is from a normal population with population standard deviation sigma is equal to 6. Now, therefore, only this information is given and you are asked to test the population standard deviation is 6 or not. So, step 1 we will go ahead, H naught is sigma is equal to 6, that is it is a sample from a normal population with SD 6. Okay, that is your step 1. Step 2 is H1 is sigma not equal to 6, that is the population SD. Just repeat the statements of H naught only with we say that it is a sample from normal population with standard deviation not equal to 6, that is your H1. Okay. So, it is not a sample from population with SD 6, it is not a sample. So, therefore, sigma is not equal to 6. Step 3, level of significance is 5%. Step 4, you use the formula Z is equal to S minus sigma divided by root of sigma square by 2n. So, is S value is 6.3 minus 6 by sigma by root of 2 into n. It can be written as sigma by 2n also, right, S minus sigma by root of 2n. So, that is what I am writing here, 2 into n is 50, right, and this value is 0.3 into 10 by 6. So, 3 by 6 it is 0.5. So, Z is equal to 0.5. So, you have calculated Z at 5% is 0.5 and tabulated Z at 5% from the tables is 1.96, and the conclusion, step 6, conclusion is calculated value is less than tabulated value. So, H naught is accepted, H naught is accepted, therefore, it is a random sample from the population with SD 6. In this session, some problems have been worked out in estimating the interval values of a population parameter, and also in continuance with large sample test, some problems have been worked out in large sample test for single standard deviation. Based on the discussions, in the following questions can be put up, that is, what is meant by what interval estimation, brief the large sample test for standard deviation, and this question is about finding the confidence limits for population mean. Limits, as I told you, that they are the end points of the interval. So, you have to find out the interval and then take out the end points separately and write it as limits. The mean score of a random sample of 60 students is 145 with a standard deviation of 40. Find the 95% confidence limits for the population mean. Thank you.